So today we're going to cover Chapter 10, Section 4. We're going to talk about inscribed angles today and inscribed polygons. So the first thing is the definition of an inscribed angle and its intercepted arc. So an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. And then its intercepted arc is going to be an arc that lies between the two lines, two rays, or two segments. Now, we've already talked about central angles, and that's what was on the quiz that you took. So remember, when you have your vertex at the center of the circle, and then the sides of this are made by two radii, this is called a central angle when the vertex is at the center. Remember, the measurement of that angle and its intercepted arc are equal. They're congruent. However, when you have your inscribed angle, this is going to be an angle that is sitting with its vertex on the side of the circle. The next slide is going to tell us about the measurement of the angle and its intercepted arc. Notice this angle is formed by two chords here. So the central angle is formed by two radii, but the inscribed will be formed by two chords. Theorem 1010, again, don't memorize the number. You can memorize the name or what it states. It's called the measure of an inscribed angle theorem. And here it states that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So in this picture, the intercepted arc is right here. It's AC. And then the angle that forms that intercepted arc is this angle ABC. The measure of angle ABC is 1/2 of the arc measure. Or if they give you the angle, you can double it to get the arc. So for example, let's say I tell you the measurement of angle ABC here is 30. Then its intercepted arc will be double that, and it'll be 60 degrees. So again, remember with the central angles, the central angle is equal to the arc. However, the inscribed angle is going to be 1/2 of the arc. The next one is called Inscribed Angles of a Circle theorem. And what this one states is if two inscribed angles of a circle intercept the same arc, then those two angles are congruent. So for example, if I have angle 1 and I'll trace over the two chords that are forming it, these are the two chords that are forming angle 1. Notice its intercepted arc is AB. Then if I trace over angle 2, notice its intercepted arc is the same. So when they have the same intercepted arc, then we know that these two angles are congruent. So angle 1 and angle 2 are congruent angles. They're congruent because they have the same intercepted arcs. Next, we're going to do some definitions here of an inscribed polygon and a circumscribed circle. So an inscribed polygon is a polygon with all of its vertices on a circle. You could sort of think of this word as being like it's inside. It's an inside polygon, or it's inside the circle. So an inscribed polygon is a polygon that's inside a circle and it's got all of its vertices on the circle. Then a circumscribed circle is the circle that contains the vertices of an inscribed polygon. So you can describe these two pictures either way. You can either say that the first picture is an inscribed triangle, or you could say it's an inscribed quadrilateral, or you could say the circle is circumscribed about the triangle. That would have been the first picture. And then, or you could change the last word here, and it would be referring to the picture on the right. You could say the circle is circumscribed about the quadrilateral. Either way. Or if you use the word triangle, you would say it's an inscribed triangle. Maybe somebody picked it up and took it to student services. The next one is called the inscribed right triangle theorem. And this one states that if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So for example, if you recognize that this angle here, ABC, if you recognize that it's sitting on the side of the triangle, the angle is sitting on the side of the circle, you can recognize that this is actually an inscribed angle. And if you look at it, notice where it hits the circle. This is the endpoints are at the end of a diameter, making this over here a semicircle. And remember, an inscribed angle will be half of the measure of its arc. So since this is a semicircle arc, it's 180, making this angle half of it, making it 90. So it sort of makes sense, this theorem, that when you have an angle that is inscribed if the one side of the inscribed triangle is a diameter, then the triangle is a right triangle, and this angle opposite the diameter will be a right angle. Now you could, because of the words here, if and only if, you could also say it the other way. You could have also said that AC is a diameter if and of the circle, if and only if the measure of angle ABC equals 90 degrees. So again, you can either start out by saying the measure of ABC is 90 if and only if AC is a diameter, or say it in reverse. AC is a diameter of the circle if and only if the measure of ABC is 90. Just remember that the measure of that inscribed angle will be half of its intercepted arc. And in this case, it's a semicircle, and you should know that a semicircle arc is 180. 180 divided by 2 is 90. So our inscribed quadrilateral states that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Now remember, back to our quadrilateral chapter, remember when we had parallelograms, opposite angles were congruent. So here we're just talking about a general quadrilateral. It's not specifically a parallelogram. So in this case, opposite angles are going to be supplementary. So angle 1 plus angle 3 will equal 180, and then angle 2 plus angle 4 will also equal 180 when that quadrilateral is inscribed. Useful fact number 1, this is really based off of what we've already seen in the notes, that an angle inscribed in a semicircle is a right angle. So notice here, we've got this angle that is inscribed in the semicircle, because here's the diameter, making this angle 1 a right angle. So if an angle is inscribed in a semicircle, it's a right angle. Because again, remember, this arc measure of the semicircle is 180. And then the inscribed angle measure will be half of that, which makes this 90 degrees. Okay, So it'll probably help if you trace over the different angles as we do these. So it wants me to find the values of x and y in both of these circles. They're both called circle O because this is my center point. So let me zoom in here to example 1A. I'm going to trace over the first angle that I have. And again, sometimes you're going to have to find other missing pieces in order to find x and y. But in this case, I'm going to solve for x first. And I'm going to trace over the two chords that are forming the 20-degree angle. So my 20-degree angle is right here. X is its intercepted arc. So the arc for the 20 degrees is this x. And we learned the theorem that stated that the measure of the intercepted arc of an inscribed angle will be double that. So x will be 2 times 20, and it's 40 degrees. Next, they want me to find the measure of angle y. So now it's an angle measure they're asking us to find. So let me trace over the angle that the y is pointing to. So y is pointing to this whole angle right here. Notice its intercepted arc is all the way from this endpoint here, all the way around to over here. Now, lucky for me, I found that little missing piece first. I found x first. So now, to find the measure of y's intercepted arc, I can use my arc addition, and I can add this 110 arc plus the 40 that I just found, and that's going to give me, when I add it, 150 degrees. So the intercepted arc of angle y is 150. To find the measure of angle y, all I have to do is multiply it by 1/2 or divide it by 2. So 1/2 times 150, or you can do 150 divided by 2, and you get 75 degrees for angle y. Zoom in here to 1B. Again, I'm going to highlight my pieces as I find them. So I'm going to go ahead and outline the two chords that are forming my angle 20. So this is the angle 20. Notice its intercepted arc will be double that, and it'll be 40. Now, I know it wasn't asking me to find that, but again, I'm going to fill in pieces based off my given because it may help me. So then now that I've done that, I can see that angle X here has the exact same intercepted arc as that 20-degree angle. And remember, when two angles have the same intercepted arc, they're congruent. So angle X here is going to equal 20 degrees. It's going to be half of its intercepted arc. Next, what I'm going to use is my inscribed right triangle theorem to find angle y. Because if you notice here, I have an inscribed triangle here inside a semicircle, making this angle y 90 degrees. Now, if it's easier for you to see that its intercepted arc was this semicircle, which was 180 degrees, and then divide it by 2, you can also get the measure of that angle that way as well. So you can go about determining or using the reasoning here different ways. So for 1C, this one also has a multiple different ways that I could have gone about finding x and y. What I'm going to do first is I'm going to find x, and I'm going to trace over the two chords that are forming my inscribed angle of 60 degrees. So this is an inscribed angle. Its vertex is sitting on the side. And I know the measure of its intercepted arc here will be 2 times that angle measure. So the value of intercepted arc X is 2 times 60, which is 120 degrees. Now, notice I already have the 140. So I already have 2 pieces of the entire circle. So in order to find Y, one way that I could do this is I could take the 140 plus the 120, get 260, subtract that from the total circle, which is 360, and find that that intercepted arc of Y is 100 degrees. Now, another way you could have done it is also found this angle that forms the 140. Half of it would be 70. Then you could have found this angle over here by adding 60 and 70. Get 130. Subtract it from the triangle sum. Find out that this angle is 50. And then its intercepted arc is double that. So multiple different ways you can choose whichever method you wish. Go on over here to 1D. So again, let me go ahead and trace over the 2 chords that are forming angle X. And I can see angle X here is going to be half of its intercepted arc. And its intercepted arc is 80. So making angle X here 40 degrees. Now notice this is a diameter. So both of these triangles that are inscribed here are right triangles. Or also know that this is a right angle on both of these because this is a semicircle arc. So if this is a semicircle arc and I know the one piece there is 80, then this piece would be 100. And notice I can use my congruent corresponding chords theorem. Because I have 2 congruent chords, then both of their intercepted arcs would be congruent, making this 100. And then making angle Y half of that intercepted arc, making angle Y 50 degrees. So here we were using our inscribed right triangle theorem and our congruent corresponding chords theorem to solve this. Okay, so let's go ahead and take a look at our proof. Let me go ahead and set up my 2 columns. I've got a statement column, and I've got my reasons column. I'm going to state my given. So circle O, and I'm going to just use the abbreviation, draw a picture of a circle, and these should be congruent marks. Circle O is congruent to circle P, and arc AC is congruent to arc AB. And this is given to me. Next, what I can do is I'm asked to prove the 2 triangles are congruent. So my goal here is to use one of the shortcuts that we learned a long time ago. I'm either going to use side, 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 angle, angle, side, angle, side, angle, or hypotenuse, leg. Now, you could actually use more than one. I'm going to actually just go ahead and do the proof here using angle, angle, side. So I'm going to establish that I have 2 congruent angles in this picture and then the one side, and it's not going to be the included side. So let me go ahead and see what I can state next. So I'm going to use that given. Because I have 2 congruent arcs here, AB and AC, I can use the congruent corresponding chords theorem to say that the chords are also congruent. So that's what I'm going to state next, that AC is congruent to AB, and these are chords. So now I can say that this chord is congruent to this, and the reason is the congruent corresponding chords theorem. Because if the arcs are congruent, then their corresponding chords are also congruent. And I can use this because the circles were given to me as being congruent. Next, I'm going to go ahead and talk about the measurement of that arc. So I know that the inscribed angle, so that, for example, the CEA here and the BDA, these are the angles, the inscribed angles that are forming that arc, which is congruent. So I'm going to now state that angle CEA is equal to half the measure of its arc. And also angle BDA is also half the measure of its arc. And the reason why I can state this is the theorem that is called the measure of an inscribed angle theorem. Because I know that the measure of that angle will be half of its arc measure. Now, because I was told that arc AC was congruent to arc AB, that was my given, I can now do a substitution. So now what I can do is state that arc or angle CEA is equal to 1/2 arc AB. I'm substituting. So substitution. And now, because I know that angle BDA also equals 1/2 AB, I'm going to do a substitution again. And I'm going to substitute angle BDA for the 1/2 AB. So I'm going to do substitution again. So now I can say angle CEA is congruent to angle BDA. And again, substitution. So now I have an angle marked. I've got a chord marked, and as marked as congruent, I need one more angle. Now, because both of these angles that I'm going to mark next are inscribed in a semicircle, or it's an inscribed right triangle, I can now state that angle B equals 90 and angle C equals 90. And my reason is the inscribed right triangle theorem. Because these triangles are inscribed in a semicircle. And that forms a 90-degree angle and a 90-degree inscribed angle. So because both B and C equal 90, I can do substitution again. And I can say that angle B is congruent to angle C. And this is substitution. And again, I can mark it here. So now I have two angles and the non-included side marked as congruent. So now I can state that triangle ABD is congruent to triangle ACE, and my reason is angle, angle, side. So again, what we'll end up doing is doing some more proof practice before I test you on a proof. There aren't any proofs in tonight's homework or tomorrow night's homework. Again, it's just a lot of practice of all of these theorems and definitions. If I decide to give you a proof on the test, I will give you maybe a homework assignment with a bunch of proofs on it, just to get you ready. All right, so this is it for the notes on 10.4. You have the 10.4 day 1 homework. It's on big ideas. And then tomorrow night's homework will be 10.4 day 2.